Hi, I'm Andy from Seraph, and if you've looked at our Instagram, you've probably seen a ton of AI-generated art. In this video, we're going to go over the behind the scenes and see how this works. We're going to see how AI generates art. First, let's look at how we represent images mathematically. Images use the RGB color model, and if you've looked at an image, you'll probably see that it's a set of pixels brought together. Each individual pixel has a red, green, and blue channel. The value of the red, green, and blue channel, you can change them to get different colors. And each channel has a minimum value in 0 and a maximum value of 255. So you can represent each individual pixel as a matrix of those three values, red, green, and blue, from 0 to 255. And you can represent an image as a matrix of these pixel values, so a matrix of matrices. And that's how you represent images mathematically. Now, let's say you can generate these images. AI, it's just a statistical model, and there's a ton of models actually out there that can generate art. The model, it's just a mathematical function that you use to make a prediction. And probably the first statistical model that is taught, the most common, is called linear regression. And if you look at it, you'll probably recognize it from like first grade. Remember, y equals mx plus b. So yeah, you probably remember that. So if the equation is this and you plug this in for x, then you'll make this prediction. And that's like a very basic model. Now, linear regression's a bit too simple to generate art. Instead, we're going to look at something called a VAE, or a variational autoencoder. And there's two parts to the VAE. The encoder in the VAE, it takes a numerical input, and then it maps it to a normal distribution. If you look at this code right here, which I kind of appropriated from the book Generative Deep Learning by David Foster, great book. But if you look at the code, you can see this z-mean and z-log-var. It represents the mean and then the log of the variance of the normal distribution that you're mapping the image, the pixels of the image onto. So the encoder, you map the image values to the normal distribution. Now, once you have that distribution, you have the decoder, the second part of the VAE, which is actually used to generate the images. Now, the decoder is the reverse of the encoder. It takes a set of numbers from the distribution and then expands it back out to get the full mathematical representation of the image. And it does that by just a bit of matrix multiplication. You can see these convolutional layers and then these transposed convolutional layers. That's just matrix multiplication to either shrink the image or expand it back out. So that's how AI generates images. It's pretty cool. You can just take a bunch of noise, throw it in the decoder, once it has that distribution, and then it'll spit out, a cool image. Now, if you want to see the code, I have it linked in the GitHub below. If you're interested on practical applications of AI and how it can specifically help your business, we have a free ebook, which is linked below, that I'd recommend to check out. Both things are free. And if you have any thoughts, questions, feel free to like, comment, or subscribe. Thank you, and have a wonderful day.